Thanks a lot. Okay, so LTE is quite a buzzword these days. Actually, it's getting to a very interesting direction for us hackers because it's going toward more accessible hacking of this domain. And it's been too long, telecom has been secluded into an area where to get your hands on actual telecom equipment, it was quasi impossible, except if you wanted to go for the black side. So first, I'm going to talk a little bit about this LTE network environment. Of course, when you talk about telecom, you talk about big irons machine. Each machine is actually always a cluster, always in high availability setup, always carrying around hundreds of thousands of people to 1 to 2 million subscriber. For example, right now the mobile switch, the MSCs, MSS, and MMEs, which basically know where you are and get your communication to you, manage up to 2 million people. So of course, when you DOS one kind of equipment like that, it's quite a lot of people that you're actually targeting. What's interesting is now, since other buzzwords have come in the domain, such as, for example, virtualization and cloud, companies like HP, for example, are working aggressively to enable you to run all this infrastructure in the cloud. So we are not that far from a crazy time when you'll say, oh, I instantiate my new 5G operator on Amazon EC2. Okay, it's far-fetched, but they want to get there. And what's the benefit for us is that everything that you see here, we're starting to be able to replicate that into simple virtual box. So what that means is that you can do deep instrumentation. You can actually try to find vulnerabilities within some of the most critical code that exists within these networks. Here, what we are going to focus is mainly on how to hack into two of the network elements which really interest us, which are the MME, which is the equivalent of the MSC, so the mobile switch in 4G LTE networks, and also in the HSS, which is the successor of the HLR. So first, one thing that we have is that, and this is blah blah, this is going to help attackers. And one thing above most of all the factors is actually something underrated as a security mechanism. The first security mechanism protecting the internet right now, in my opinion, is NAT. And yet everyone agrees to say that it's not a security mechanism. Well, for the worst or the better, what happens with LTE is that they are really deploying IPv6 in these networks. So that means that NAT protection is dead. Now you have an IP back, and as we've seen this morning in the presentation, it's getting, for example, on the SSRF, it's getting very easy to actually practically use IPv6 in order to hack into this network. So now Van Houser can actually really put to application all the hacks he's been doing for 10 years. The change that happened is that many network elements got actually merged into simple box that now all run Linux. So it's not a matter of, okay, what kind of operating system does it run on? You take Ericsson, you take NSN, you take Huawei, you take ZTE, you take maybe even Alcatel-Lucent. So the French are not that lagging anymore. Incredible. These are running Linux. In the past, these were only running monolithic VxWorks with monolithic development, crazy amount of data running on FPGAs with specific hardware. One thing that they did is that the vendors and the operators standardized the hardware in order to run the same hardware everywhere. Of course, they managed to screw it up and to actually make it incompatible. But that means that it's x86, it's Linux-based, and you can actually quite easily dump what's on it. What's interesting is that the eNodeBs now look very much like femtocell. So if you hacked into femtocell, basically that's really going to look very much like what you're going to do if you hack into eNodeBs. Also, what's interesting is that very often some of these big irons, specifically the ones that are doing a lot of data processing, like signal processing, are going still to use some hardware features which are hardware boards. And all of them will be actually running some FPGA cluster. So once some person was demonstrating to me what we had hacked into, goes into the data center and grabs like a sub-rack and plug it out while it was blinking. And I'm like, whoa, guy, this is a bit dangerous. He's like, whoa, don't worry, it's hot swapped everywhere. So this stuff is actually what we are hacking on. The only stuff we are not going to be able to virtualize yet, and what we didn't manage to instrument really deeply, is actually the FPGA code, which we only have bitstream for inside these specific dedicated blades. Otherwise, the rest, it's quite something which can be opened and dissected through normal techniques. So what's interesting is that LTE actually brought into this domain new protocols, but reused the old ones. So all the different network elements that we've seen, what the specification and the industry tried to do is to merge them in order to have a single set of protocols. And what happens is that they wanted to go for full IP only with these new protocols, which are mainly S1 and X2, AP, and diameter. And of course, now the mighty SIP that is there to replace all the old telecom technology. Well, actually, what happens is the exactly opposite, is that you don't find right now a single operator in the world which has LTE who doesn't have at the same time a full setup of his old legacy SS7 and SIGTRAN setup. So that means that instead of reducing technology, we just multiplied it by 2. So in terms of direct attack surface, that means that you're not now protecting only GTP, you're protecting GTP plus S1 AP plus X2 AP. You're not protecting anymore SIGTRAN and SS7, you have to protect diameter on top of that. And all of these have to be understood as little tunneling protocols, which are going to be able to channel data between the different components of a real operator. And this is not a real operator. What's missing here? 2G. Of course, if you have an operator that's only doing 3G or 4G, well, sooner or later, it's going to be acquired by the one who are really having the big customer base. So the people who don't have it are doomed, so they all want to be compatible with their legacy. What's happening is that to support this legacy, the telco have deployed one thing that is quite efficient, which is called CS fallback. So you're happy with your new phablet surfing on Facebook, as you all do, I'm sure, and you're then having a call, or you want to make a call. And what's happening is that you are going most of the time to switch back to the 3G or 2G network. It's called CS fallback, circuit switch fallback. And when you do that, actually, all the technology from the past are present again. And most of the time, it's either due to some media gateways or to some MSC proxy, which are actually going to proxy everything that's coming from the SS7 side back into the LTE side. So LTE, sometimes the core network, you'll hear about it called EPC, Evolved Packet Core, or SAE, Service Architecture Evolution, etc. Okay, so what you have is some operators are advanced and they say, okay, we don't want CS fallback. And they go for what is called voice over LTE, which is actually just voice over IP with a specific APN to connect to this quality of service guaranteed network. So what happens is that you have, of course, some new servers. So it's a new attack surface, and since it's new, the maturity of it is not yet proven. Also, you have new APNs in general which give access to a whole new set of networks. Each time you see a new APN, you see the silly internet that you enter when you have a new cell phone sometime. Well, this stuff gives access to, let's say, a wall /8 behind it all the times. Because all the time, you'll have at least a 10.something network class that hosts all the network elements from the LTE network. And of course, you'll have hundreds of 192.168 RFC 1918 networks, which also host some dedicated and specific networks. So what you have is actually an overlap of a lot of different networks. And that's what you are supposed to actually qualify horizontally by scanning this, and also vertically. And what happens is that since on this vertical stack, they piled up stuff that we know, now we know even much better how to get into these, because this is actually just standard SIP. And in SIP, we are going to encapsulate some information which is actually direct SS7. It's called ISAT injection. So what we see is that we exploded the number of APN and /8 we need to scan. And we did also an explosion in complexity in terms of actual protocols that you can tunnel one into each other. And half of them are totally new with new code base that probably was not as checked as the old code base. So what happened here is that you're going to be vulnerable as a network operator to the old SS7 attacks. So I listed a few here. Who knows about SSP-based SCCP DOS? Point code prohibition, global title prohibition. Okay, that stuff is going to die with Raoul and me, who are the old dinosaurs of this domain, and basically the new guys coming into the network who want to do assessment of the security. Basically, they will go over that and say, yeah, this technology is going to die. This is a legacy sandwich. We're not going to deal with it soon, and that's wrong. SS7 is here to stay at least for a good 10, 15, 20 years. What's interesting also is that what the big vendors said, typically Ericsson, Nokia Siemens Network, Alcatel-Lucent, they said, well, guys, this network is secure for two reasons. One, it's proven. Two, only nice people can get into it. We're into it. Are we nice people? Let's hope that. But what we see on the network with the amount of hacking is that, of course, they are not only nice people. And is it proven? No, it's not proven. What we find in the last year, and that only in the last year, we managed to crash Ericsson MSC with malformed SCCP traffic. That means that you could say, yeah, but it's old system. No, that's just the latest R14 release of the Ericsson MSC. And the simple reason is that we send with an interface, which is the old interface that should not be present anymore. And it's a bit like if you were combining, saying, I'm sending GTP version 0 on the port dedicated for GTP version 1. So what happens is just by silly inversion of protocol sent to the wrong port, we trigger this bug. Okay, it's a lack of luck. It's not. One thing interesting, the fuzzers that these people are starting to use, they're saying, oh, but we use fuzzers. We use that to qualify our SCCP stack, or it doesn't go that deep. So we're going to talk about fuzzers in a bit. So all this stays, and we now have to deal with all these vulnerabilities. So I listed a few. That was the one that I listed about NSN and GHLR. We have also some interesting thing is that we have one level of tunneling, we said, which is SIGTRAN, tunneling SS7 over IP. We have then some tunneling of information about mobility that is done by map. And I forget about the routing and the encapsulation, which is also some encapsulation there. Now, what's interesting is that you can also embed into SS7 some radio signaling saying, oh, by the way, your base station is saying something to your MSC. But bad luck, this is coming from the outside, from the international network. So how could that happen? Is that we are not even mature in SS7 in terms of filtering. So the very interesting thing here is that it's a perfect storm for it coming. And what we've seen at some operators is that we were discussing with them, and they say, yeah, we're not sure about the budget, you know. This is security, and our problem these days is mostly with HLR and MSC crashes. Okay, isn't this security? So for them, this is budget that they're giving to the vendors who are already failing at providing diversity of protection, either in defense in-depth protection, good fuzzing and security Q&A, basically not in a good sense. What's even more funny is that these guys are still good at really one thing is doing development programs. So in their development program, they mutualize the code between the analysis tools, the forensic tools, the actual enforcement tools, the routing tools. So when we found a bug about Ericsson STP, and Ericsson tried to reproduce this bug by reading our traces that we generated using their tool crashed too because they were sharing the same code base. So that means that with the same kind of vulnerability, you have both server-side exploit and client-side exploit. Now, let's talk about something that is in contact with us. So what is in contact with us is actually these little things called eNode Bs, which are directly providing to us the radio signal. So remember, this is just Linux systems running most of the time Linux 2.6.16, and with some good code on it. What's happening is that they did a very smart stuff. They introduced into the network some peer-to-peer concept. And the goal of this peer-to-peer concept is very interesting and very nice. When you roam from one eNode B to another eNode B, what's happening is that the first eNode B is channeling the leftover of the traffic to the new eNode B. Okay? So they have to talk peer-to-peer between two roaming eNode Bs. What it has as a consequence is that all the eNode Bs of an operator needs to talk with all the rest of the eNode Bs. So remember how the old principle of 2G and 3G worked? You had RNC, which were the radio network controller, or BSCs, base station controller, that control only a small set of little base station transceivers. Okay? Now what we have is a fully meshed, totally interconnected at layer 2 of all the eNode Bs within an operator. So what does that mean? That means that it suffices to get into one of the protocol, one of the eNode Bs through these typical protocol which have been proven vulnerable, GTP, both on the user plane and on the control plane. And you're going to be able to jump from one eNode B to the other, or to try to access something else on this big L2 network. So what's interesting here is that, of course, at the layer 2, there's always some guy who connected the wrong switch on the wrong other switch. It's always happened. Tell me one person who didn't have that in this room as a security problem through his career. One person? I wouldn't say so. We always have done it. Beat me, I've connected the wrong switch onto, it's easy, and usually it doesn't matter so much. What's interesting here is that these eNode Bs, most of the time, they need to be provisioned. So you see the guy who comes into a new cell station, he racks his eNode B, and he has to make it auto-provision. Well, what's funny is that in theory, all this stuff use certificate-based authentication. It's very nicely done. And most of the time when it's done in production, it's actually the guy with a USB key who puts his USB key into the eNode Bs and configure it from here. So what we have is actually many examples of being able, through the L2 network, to connect to the, what we call OSS, Operational System Support, which are actually the systems which are going to do the provisioning of all the eNode Bs, which are going to be doing all the maintenance, collecting the traps and errors and debug reports, etc., etc. And what it looks like is actually just like this. It's just like a big rack, which in the past, this stuff used to be TDM network interfaces. So does anyone has a TDM card on his laptop now, or in his bag or at home? Raise your hand. I do. Nobody, right? Nobody cares about TDM anymore. And anyway, back at the time, nobody had even these interconnection cards. Now, what you see here is pure DWDM, basically standard SFP ports, standard Ethernet ports that everyone can connect to. And what happens is that already in several 3G, it started to happen, but now in LTE networks, some people are showing up with crowbars, open this very nice cabinet, and just plug to the network, L2 Ethernet down to the rest of all the eNode Bs and operational support systems. So what's interesting also is that on some vendors, what they did is that they replaced the hardware monitoring modules by IP hardware monitoring modules for physical intrusion. So the principle is that you have a little loop. If you cut it, there's no current going through the loop, so alarm rings. So they did something very smart. They took this alarm loop and they said, oh yeah, Ericsson's version is a bit too expensive. We're going to replace it with our own. And what they did is that they did it with a manageable, super fancy kind of hardware monitoring probe. And the hardware monitoring probe does one thing. It does, if the loop is disconnected and no current flows, then I send a packet to OSS saying someone is intruding into the base station. What's the vulnerability here? Cut the RG45 cable of the alarm system. No packet, no alarm. So the whole point of having this closed loop with electricity in order to actually detect this stuff, which is quite costly when you don't have it, but is even more costly when you have no service into an area. Well, what happens is that they made it totally wrong by having a security system which doesn't work with this closed loop mentality. So, very funny. So with this stuff, you can connect here to some optical backbone, and this optical backbone gives you access to actually the OSS. And from there, from the OSS, we are going to see what kind of stuff we are going to talk with. Also, in terms of attack surface improvement, you don't have only what we've seen in terms of network space, but also in terms of depth of protocol, of these new protocols, which are Diameter and S1 and X2. Who worked with Diameter so far? Yeah, well, okay. 3 people. And with S1 and X2? 2 people? Okay, 3 people the same, okay. So basically, this stuff is for Diameter just a radius on steroid, extensible radius. But there was some problem with radius. There was this silly authentication, which was called the radius secret. Why bother? It should be provided by upper layer. Everything should be encapsulated into IPsec. So they removed this radius secret, which is not anymore present in Diameter. How useful. And now we have these S1 X2 APs, which are basically encapsulating protocols. So what it means is that we have new encapsulation with now even some traffic which is encapsulated, which is directly flowing from the UE, the user equipment, into the core network, thanks to the eNode B using S1 and X2 and Diameter. And what that means is that you have direct signaling with no modification, which is now flowing from the external user-controlled devices directly into the core network. Of course, it has to be handled and treated, no problem. But the problem is that with this kind of exposure, you know the kind of problem we are going to be facing. Also, what's interesting is that Diameter is now also an encapsulating agent. And it's an encapsulating agent which is carrying now so much interfaces that what you have is really concentration. And what is in the dogma of Diameter is that there should be one central router for Diameter, the Diameter agent or Diameter routing agent or Diameter signaling router. And it should carry everything, and everything that does not go on Diameter should go in SIP. Well, the problem with Diameter is that when you look at it, and when you look at the actual packet and at the specification, you read that the actual specification does not force you for anything. Nearly every attribute value pair is optional, and it only depends in one kind of dialogue you are to put this kind of attribute value pair. So what happens is that when you have this kind of protocol, it's depending on the dialogue, the flow, the business process going on with the user, with the subscriber, there's these AVP combinations that you need to do, which are specific to that. The AVP values, some of them must be fixed, and within all this address space, all this problem space, you need to fuzz the content of diameter. That means that when you fuzz, most of the time, you're just flowing some hot air onto your machine. Does it crash? Does it crash? No, of course it does not crash, because you're not actually triggering any basic block which is processing your stuff. It's being blocked before that by the decoding engine, which is going to say incomplete, 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 I don't process. And what happens is that if you don't have actually a fuzzer which can replicate this diameter flow, not only like it's a full context, so basically we are talking about finite state machines, you're not going to replicate anything that's going to crash the network element. And what happens is we went from 0 trigger on only 1,000 iteration. Okay, nobody does 1,000 iteration into client-side Windows-based fuzzing farms. We are talking of billions of iterations. Well, in this case, only with some improvement into doing the custom tools and then improving, basically getting into real fuzzing, went up to 85 on 1,000, 85 triggers on 1,000 iteration of fuzzing. And this kind of statistics, if you talk to the Adobe or Microsoft guys, they would look at you in horror and say, poor guy, you really need some help. This is really bad metrics. And we are talking about what is called critical infrastructure equipment. So what we can do is actually say that diameter is the famous XKCD example that, oh, we need a new standard, and they create a standard to simplify the 14 other competing standard like definitions, and now you have 15 standards. And that's the same thing. We need to keep SS7, we need to keep all the SIP and stuff like that, and we now have a new standard. So let's get specific and see on a typical LTE equipment what that means. We'll go with Huawei, which is a very popular also provider challenging Ericsson in their leadership position for telecom equipment. And what they have is they are totally going toward this ATCA kind of virtualization mentality. They want to have standardized x86 blades. They want to run things in virtualization. And what happened is that they started to put all the different components into one or many box. And now there's even one box, the EHS something, which is combining both the MME, the packet management systems such as the PDN gateway and serving gateway, all into one box. And what is that box? It's just Linux with a few FPGA-based specific hardware. So what is interesting is that if you remind what we were doing, we managed from the eNode B to get access through L2 misconfiguration to OSS. And from there, we were, okay, what can we do? Okay, so the way we got into the OSS was not very nice and not very sexy. It was due to stupid misconfiguration, but yet it's quite the case in most of the LTE operators that we've seen. And then the question was how to get to the Holy Grail and actually go toward the HLR, the HSS in LTE. So what's interesting is that all these kind of systems are usually big, fat binaries which are actually developed in C++ most of the time, connected to database backend and with Java and some FPGA, basically connection port. So that's the typical mix. And here in this IDA representation, there's something that should like bump into your eyes and make you scream. Is there something here really weird? For some stuff which is critical. Do you see it actually? Maybe not. There's SQL injection everywhere, and if you see every symbol is exported like publicly, there's absolutely no sense of security. So when some people want to tell you we are doing security, at least the basics are here. Here, it's not talking about the basics. Maybe the basics are considered to be regarding the user equipment, but we see that by a trigger of L2 hacking, insecure defaults and misconfiguration, you get to the inside of this equipment. So what we have is very simple stuff which enable us to cascade into the core network. From here, we are into the database of the HLR. That's considered game over. If we take that out with a simple drop statement, there's no authentication anymore for all the subscribers of the operator. Now you could tell me, well, these are heavily replicated. These are cluster-based systems. That's right. But the database has to be unique. The database, even clustered, has to have a single representation. You do the drop statement, you're dead. So you'd say here, that simple thing that we see everywhere. But the problem is that the vendors are not really into this dialogue, this creative dialogue with researcher. When one researcher say, I pwned you, and they say, yeah, we are coming back at you, and now this is more secure. And basically, you don't have this kind of creative and sane and sound dialogue. Also, the thing is, very often it's considered to be in a perfect world. So what happens is that the vendors are deploying and releasing equipment based on the standards, and then they give it to operators, and either they deploy it for them, or they deploy it themselves, or the operators deploy it themselves. But the design is considered totally different from the production, which is not my work. Okay? So the consequence of this is that everything is, we do only this part of the work, and the rest should be secured by IPsec. That's the mentality. So it's encapsulating everything, and you know that to make things work, well, some people have to take shortcuts. And the single shortcut that is taken, there's no defense in depth, so all the securities that was supposed to be believed perfect thanks to IPsec encryption, well, on this side there won't be IPsec because it doesn't scale, then you don't have any security. If you look at the complexity of it, it's already quite complex as is. But that's not the reality. That's the reality that actually the people doing specification see. The real reality is this on one layer, put it flat, and stack layers of stuff on top of that. This is another layer. And there's on top of that another layer, which is just the media. So what we see is we have a stacking of communication. With this complexity, it's impossible to make things completely right, and it's very hard to scale with total security. Also, one thing which is interesting is that when you do qualification of LTE testbed or LTE production, you always think that I've done it before, my Nmap is going to take quite some time, but it's okay, I have 2 days in front of me, it's going to work. And it doesn't work at all. The reason for that is that we are not into the same world where you have one Ethernet plug and you have one network. We have one Ethernet plug on maybe hundreds of different small 192, 168 networks. Each of these is one network element. So if you connect to, for example, to the Huawei HSS, the network element in itself to connect all the clustered instance is going to have one network 192.168/16 and one 172.16/20-something. Okay? So what we have is that we have an enormous complexity of network, and on top of that, each of these elements may have a hidden universe. For example, the hidden universe of everything doing packet data is the APN dimension. So if you take the APN, which is used for VoIP over LTE, that's one network which has its own size of IP addresses. So we are talking already about 16 million addresses to scan. And then we have another network, which is the normal internet connection. And you have something like 200 for a typical operator, between the test APNs, between special offers, between the MMS APN. Okay? So basically, that's impossible to do manually. If you try to do it, of course, you will fuck up like everyone trying to do the security by hand did. One thing that is interesting also is that within these network elements, many things are inherited from the past. So what we have is we have some people who came into the domain and said, listen guys, we need to have security. And what happened is that security is actually very often understood as a magic spread, which has a funny taste, and you spread it over any kind of code, and suddenly it becomes secure. So for example, we had an insecure configuration file with injection, and what happened is that the security that was added on that was to actually put a hard-coded desk key into everything that needed to write or read from it, and then, since it's encrypted, nobody can manipulate that. So what we had is a funny example. I'm going to try to see if we have that. Yeah, you can see it. Okay. So we have this kind of little file, of course, well secured. And what you have is actually something which is just a dumb DES encryption. So first, we're talking about DES. Here we go. So this is the kind of security that you have into this equipment, is that by just adding sprinkle some IPsec and put some DES there, then suddenly it's secure. And what you don't have is any kind of real proper well-thought engineering in terms of security there. So the thing is, this stuff is not only related to the inside of machines. It's also related to the overall network organization, but don't think it's limited to L2 stuff. It's also going over this. Everything that is systemic is quite well done. So, for example, what was really well done is how between operators to enable roaming between users from one country to another country. Well, what is very unique here is that they used a proven technique, which is a DNS, proven system, in order to distribute this information. So that was actually a very good idea. And they said everything must be encapsulated under IPsec again. And what happens is that, of course not. Of course, some systems, last time we had a GRX audit mission, it was end of last year, there was some Solaris 2.6 box, which were with a login root, password root, no IPsec, directly onto the GRX network. And hacking into this is as easy as getting into the first unknown operator with no security budget, which is present on this network. So, in theory, everything in telecom is very neatly defined. But when you look at practice, everyone is, oh, but it has been really specified. It has been really decided as secure. So now what we see is we see some effort about regulation of how to secure the network element so there's no leaks, how to secure, and here one thing that is quite important is that it's not by specification that you're going to ensure security, it's by testing it. And this is not yet there. So what's evolving is that we don't see too much of the security effort, except in some specific operators who are doing this work and pressuring the equipment manufacturer to do so. But what we see is that the other operators are pulling more and more information into these insecure systems. So back in the days, on this IDNS, the private DNS of all telecom industry, you had only basically the APN and which APN was on which operator. Now you have the location of the equipment, the area code, which enemy is responsible for which location area, which HSS is present at what IP address, etc., etc. Even the identities of the users are starting to be stored into these. I'm not even talking about enum, the mapping of phone numbers. This is not even it, it's just internal information. So we see that it's exploding and already it's not secure. Okay, now, really what's interesting is, okay, he's been talking about that, blah, 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 this big iron, that. How do I go from here? How do I pawn my LTE operator? Well, once again, may not be glorious, but it's actually super simple. The thing you are having, and it's a marvelous tool, it's called NAT. And in this domain, NAT is going to be super useful because when you're NATed, you don't have just your IP, which is yours, and the time where you could connect directly to other RFC 1918 network elements which were not filtered is a bit gone. We still see from time to time some network who have that, but that's not the typical vulnerability. Now, the most typical vulnerability is that when you're being NATed, the address that you're getting is actually an address from a net block, which is a net block of the operator. Right? And the operator has acquired this stuff. So what happens is that when in an operator of, let's say, 5,000 people, 10,000, 20,000 people, and that medium size, we have some firewall administrator who is defining the firewalling rules. What does he do? He doesn't want to be called every day, so he says, what are the net blocks attributed to my organization? And what happens is he puts this network into his allow list on his firewall. And that should be fine. It's the internal net blocks, right? But in these internal net blocks, of course, what you have is you'll have all the people NATed from the inode Bs directly who would have an internal net block, but basically being allowed from one of the, let's say, datacom routers into, let's say, the load balancer administration port. And that's so typical so often that you'd say, okay, come on, this is basic IP pen test. But it's basic when you have 2 to 100 devices. It's not basic when you have 2 to 26,000 devices. Okay? And that's the typical network operator size in terms of network element. And I'm talking about IP network element. For a typical size of non-IP network element, it's around 60,000. So it's easy to fuck up if you are doing stuff manually. Also, what's interesting is that you can hack from external. You don't need actually to be a customer from the operator. So this is quite fresh data, as you can see. And basically what it is some network element administrative access port. So on this port, you can enter any command that's going to change the configuration of these. And what you have, if you remember my slide, UGW is actually a merged network element of the MME plus the PDN gateway plus serving gateway. So what we have here is we have directly access to the core network element of an operator. And one operator doesn't need much of these in order to run its LTE network. Some networks are using 4 UGW from Huawei to run a whole country. Okay? So already for this guy here, there's already 2 of them who are exposed on the internet. Don't go on Shodan, you won't get these. You really need to scan for this. But the thing which is interesting is that you don't even need to go for these heavy lifting of scanning and using the crowbar onto your local LTE base station. You don't need to go physical, guys. You can do it from your home. So what's interesting is that why don't we get more notice about hacking into these, about people? One, it's not known. 2, there are people who are actively hacking into these who have no interest of having a little hacker burn their own access to the operator. And what's very interesting here is that the Athens affair, where some unknown intelligence agencies backdoored some Erlang code into Ericsson switches, well, there's a goal and there's a reason why people don't really communicate about this. There's an interest for nations to keep access to telecom operator. In terms of bias, one thing that is interesting is that most of the time we're only allowed to do testing, like hardcore testing on LTE equipment which is in the test bed. And we always say to the customer, this is more secure than it will be in production. And they look at us and they're like, what are you talking about? Now, the thing is, once again, the enemy here is complexity. So what you have is you're going to always have some of this complexity which is going to burn you and is going to compromise security. Once again, lack of defense in depth, lack of testing, and fear. People fear that they are going to crash something. Well, it's better to crash it when you're starting the network than when you have your 50 million subscribers on it. Another auditor bias is, Also, one thing which is very sad is that in terms of access, the vendors are doing some intense work in order to prevent anyone from having access to these. So don't look for research programs, don't look for actual communications of these. The typical vulnerability communication with these people, with these vendors, starts with, do you have the license for the product you are testing? Are you our direct customers? Da, 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 da. So we are very nice and doing this responsible disclosure bullshit for basically something like a couple of years, 3 years, I'd say. And at that point, we said, stop this. It's not working. These people are making fun of us. Basically, it's not being even efficient for our customers, the operators. So we said, if we don't have a commercial contract with you, we don't communicate any information to you. That's not responsible disclosure, that's professional disclosure. So what we did is we started to do that with these guys, and actually it worked much better. These people understand only, and I'm talking about the vendors, if they're paying for something, actually they are going to try to optimize and not have so many hours wasted because they pay for it. That's a bit sad, but that's what we have in there. What they are also doing is bullying the operator, saying, wow, don't talk to the independent security vendor, security researchers. These people don't know our systems. How could they know? Reverse engineering is not for frogs. Well, the thing, this is really what's breaking the security of these operators. Okay? So, to finish and to basically give you my feeling, it's really changing now just because the domain is opening up. And that's really what's going on is the progress of security in telecom is thanks to people like, I'm thinking about Colin Milliner, I'm thinking about Charlie Miller, I'm thinking about the SECTI people in Berlin, I'm talking about the people from RW. Basically, it's independent security researchers that at some point got access to the equipment and from there started to do their own research. And as we see, doing your own research is actually not very difficult. One thing that is interesting also is that due to the information leaks, now you can perfectly get a proper and good knowledge about telecom security without doing anything illegal, just by reading script or any kind of PDF hosting systems. They are unleashing tons of internal information because the vendor's strategy of not releasing information is biting them in the back. Because since they don't release information, people have to share by themselves. And they share it, of course, with social networks and stuff like that. So we have still a problem feeling a bit like the 1980s in telecom domain. You can't expect to have better security with LTE, despite the fact that LTE was built for security. And I repeat, this is something that is going not to be acknowledged by the people into this telecom industry. And only some vendors are doing some active reverse engineering program, vulnerability research. And when they do it effectively, they always do it outside of the vendors. Okay? So, thank you very much for your attention. And if you have questions, that's the moment to shoot.
Are there any questions for Philippe? We have a few minutes, so... No. Oh.
Yes.
Why do they connect the eNode Bs in layer 2? Why not in the layer 3? Why is that? Why are the eNode Bs in the layer 2 network? Why not
of course, they are also on the layer 3, but layer 3 is going to be firewalled by typically what is called the security gateway, which is most of the time co-located with the serving gateway. Okay, so you have the RAN, radio access network, and you have the evolved packet core, the EPC, and these are separated by the security gateway. So the most hack you can do is only the hacks that you can do at the layer 2 on the RAN side when you're on an eNode B. Okay? Because usually they try to do things well at the layer 3 from this perspective. It's totally different if you're the EPC, if you're into the core network, the evolved packet core.
But as I understood your presentation, all the eNode Bs are in a single layer 2 domain, but then that's not true.
Yes. Yes,
it is true.
They are into a single layer 2 network, all the eNode Bs.
Okay.
So yeah, it makes sense now. You're like, okay, in terms of attack surface, you just multiplied it by basically the square of eNode Bs.
And don't they get performance problems then? Or
I'm sorry?
Performance problems, if they have it all on the same layer 2.
Basically, you could do something totally from a configuration perspective. You could say, I'm not going to roam from France to Marseille, because the handover is going to be from Paris to Marseille. I'm going to be from Paris to Créteil, maybe. So a city which is close to each other. So you could say, yeah, I could firewall all the eNode Bs which are in one location just to access the location which are closed. But try to think in terms of firewall rules, what that implies. It's totally crazy. It is a combinatorial explosion here.
So, thanks.
Basically.
Any more questions?
Yeah, one question down
there. During the talk, you talked about having specialized scanners and specialized testing software. Can you elaborate a little bit on that?
Yeah, I'm not going to elaborate too much because it's a commercial product that we publish, so that's not the goal of security research conferences, but we can talk about that a bit later.
Anyone else? No? Okay, well, Philippe, thank you very much for a great talk.
Thank you very much. See you at Akito, May 2 to 4th. Will be my guest. Thank you.